Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Arin, founder and CEO of WebRTC.Ventures. WebRTC.Ventures is a custom design and development agency focused on building live video applications. We're here to help you take your application live. You can learn more about us at WebRTC.Ventures. Thanks for joining us live today on YouTube and Twitch, and welcome also to any of you watching a replay of today's event. For those of you with us live, you can ask questions on YouTube or Twitch in the comments throughout the stream. In today's episode, we're welcoming back Tsahi Levent-Levi to discuss the impact of new technology on WebRTC applications. If you don't already know Tsahi, you should. He's a leading WebRTC analyst, founder of testRTC, blogger at bloggeek.me, and he teaches WebRTC courses at WebRTCcourse.com. So welcome back, Tsahi.
Thanks, Arin. Great to be here again.
Always a pleasure to have you here. So I mentioned you're founder of testRTC, which was acquired by Spearline last year. Let's just start there a little bit and just say how are things going? What's going on at Spearline and with testRTC?
So it's great. Everybody says that, but we're probably still in the honeymoon part. The thing is that being part of Spearline gave us access to a bigger market with larger types of customers, larger sales team, and a lot more resources to do what we want to do. So we're now growing the team, increasing what we're trying to achieve, and the next step would be to working towards the synergies that we have between the companies. Spearline deals with testing and monitoring of phone numbers. We do WebRTC in the same domain, and there are a lot of crossovers. Okay, like getting a phone dialed from a person, a call dialed from a person on a phone towards a call center agent on the browser. These types of use cases, we can now get end-to-end for every type of thing that you need. So we're trying to look at that as well and to roll out these types of features.
Nice. Excellent. Well, it's definitely excited to hear that news for you and wish you the best of luck with continued best of luck with testRTC and with Spearline. Today, though, we're going to talk about the impact of new technologies on WebRTC. So we're going to have you put on your WebRTC analyst hat here. Mm-hmm. And let's go ahead and switch over here. You've got a few different technologies. You wrote a really good blog post on bloggeek.me back in December that highlighted some of these. And we're interested to have you kind of tell us a little bit about how these new technologies are going to impact WebRTC development, the design and development of WebRTC applications in the future. So I'm going to turn it over to you there.
Okay. So I guess the first thing to look at is the fact that we're 10 years old when it comes to our WebRTC, or 11. That depends on how you want to look at it. But essentially the question now, after we started with the pandemic and the different waves of COVID that we had, have WebRTC peaked? What we see now, this is like the calls to get user media in Chrome, in the browser, and the percentage of page views where that call is being made. So before the pandemic, you see that it's at 0.05% or something like that, and then the jump comes in up to 0.6%. This is the second or third wave, I think. And what you see here is that there is an increase, and it's not going down from here. So today we're like at 4 times the increase in use. That's because of work from home, remote work, healthcare, education, new use case, and other things. A lot of these different use cases are going to stay with us even after the pandemic is over. And we're also talking about post-COVID and companies going back to work, but now work is going to be slightly different. People are going to remote work parts of the time, some people all the time. So the world is changing, and this increase, I think that the 4 times increase is going to stay with us. If we look specifically at WebRTC and where we started at, it was in 2011, something like that, and until 2014, it was the era of exploration for WebRTC. The main question there was, should I use WebRTC? Okay. Browsers that used WebRTC or WebRTC were available at the time were Chrome and Firefox, nothing else. In the next era, 2015 to 2019, it was an era of growth where the question changed to how do I use it? It was no longer a question of, is this something that should be used? Is this something that's going to stay? We understood that this is going to stay. And the main question now is, what do I do with it? How do I call the APIs? Additional browsers joined, Edge and Safari, and then we got all of the modern browser support for WebRTC. Working some of the time, there are differences in behavior, everything is correct, but still, we now have it available. Somewhere at the end of 2019 and even before the pandemic, things started changing, and we switched towards the age of differentiation, where we knew how to use WebRTC. We saw use cases out there that are working in production, and the question then changed and shifted towards how do we compete? How do we win in our own markets? Into this question, there are a few aspects that come in. First of all, version 1.0 of WebRTC got officially released. Nobody cared up until that point, but now it's official. Then we had Zoom coming out, and everyone today that builds something with WebRTC competes directly or indirectly with Zoom because he is being asked and compared to what Zoom is capable of doing. And we had this pandemic going on that brought us into this huge explosion of WebRTC. And the question that is being asked now is, okay, what's next? We're 2022, starting the year. What's going to happen with WebRTC? What can we expect the new things to be, the trends, the uses? And I want to talk about the technology parts of it at the moment, okay? And in the technology part, this can no longer be the question. How many video tiles are enough? Is 225 enough? When we started the pandemic, it was 49. Now it's 100 or 200 or what is the number? And where do we go from here to 1,000? At some point, you can't see anything anyway. So this isn't the way today to differentiate the things that you are doing, and almost nobody is going in that route. What we do see is new technologies that are coming into WebRTC and are being used with WebRTC in one way or another. These technologies today are WebAssembly, WebTransport, WebCodecs, and AV1. And what's happening is that if you look at WebRTC NV, the next version of WebRTC, the one that is being discussed, it's mostly about unbundling WebRTC itself and picking and choosing the lower level stuff that you want out of WebRTC, putting controls over them so you can do whatever you want. And it's less about built-in features that are available for you out of the box. It's not new shiny toys, it's rather taking WebRTC, unbundling it, tearing it apart, and then rebranding or repackaging each one of these pieces. And these are, again, they're enabled by WebAssembly, and these pieces are WebCodecs and WebTransport, and we have AV1 on top or next to all of that. Let's go one by one to see what they are and why they're important. But first, let's look at the WebRTC media processing pipeline. In WebRTC, we've got a camera and a microphone. We grab the data from them, move it, and capture them. Okay? Once we capture that data, we encode it. After encoding, we send it over the network. That thing got sent. On the other side, it is received by someone. The receiver sends it to the decoder. The decoder plays it to the display and to the speakers of the device. This is WebRTC, or this is the pipeline in WebRTC for media processing. What is happening today with all of these new technologies is that we're tearing it apart. How are you doing that? It started by this. We had insertable streams coming up sometime last year, I think, believe in the beginning or even before that, where what we did was take the data out of the encoder, so the frames that were encoded, sent them out into an external function of the application, and got whatever was done here to be sent out instead. So now I can do things like encrypt again, to do end-to-end encryption in large group calls. Okay, things that was impossible to do before that. The next thing that we had on top of insertable streams is another type of insertable streams, also known as breakout box, where what we did was roughly the same, but between the capture and the encode, and between the decode and the playback. So now if I'm here between the capture and the encode, I can do things like replace the background, or put a silly hat, or do other things, okay? Now that we've touched these parts, I want to do other things as well. I want also to replace the sending and the receiver with WebTransport, so I can send whatever the hell I want, whenever I want it, and not be reliant or I don't have the need to use WebRTC, because WebRTC is heavy, okay? So I can unbundle the sending part and call it WebTransport, another new API for the browser. I can do the same for the codecs using WebCodecs. So now I can encode and decode frame by frame without going through WebRTC. So now I can, build whatever I want. This is get user media. It's available today in WebRTC. I can take get user media, use a breakout box or not into the web codec. From there, send it to the transport and do the opposite on the other way around. In order to do all that, the glue that keeps it together is WebAssembly. Why? Because it's faster. Okay? With WebAssembly, what we essentially are doing is taking a language, usually something like C, C++, or Go, or Java, these kinds of languages, and then we go and cross-compile them into a WebAssembly binary file. And that binary file gets interpreted or run with a just-in-time compiler or execution inside the browser itself, similar to a virtual machine for Java. Okay? That way we can run things closer to the machine and do things around machine learning that we couldn't do without it using JavaScript in a browser. And a lot of things today are using that in order to do the things that they need. One of the things that I've seen recently is taking the libraries from WebRTC, for example, the sending and the receiving part, all of the logic of jitter buffering and RTP, and just cross-compiling that from C++ to WebAssembly and using that on top of WebTransport. Why? Just because. The next one is WebTransport. WebTransport, in order to understand it, we need to understand where it lives and resides within the different types of transport protocols in the browser. We started with HTTP, and HTTP is a centric protocol, client-server, that's it, and it's very reliable. You're sending a message, it either got received on the other end or the connection is lost. From there, we went to WebSockets. WebSocket is still very reliable, but it is more flexible. I can now send data from the server towards the client wherever I want, but it's still client-server. Then we came with HTTP2 that is better from HTTP1 and a bit more flexible, but in the same vicinity. WebRTC came, and that was the total opposite. It's fully flexible and with very low latency. Reliability is here in front of latency because if I'm reliable, I need to wait with the messages that I'm receiving before understanding if they're good or not, and I need to allow for retransmissions. If I'm going to somewhere that I want low latency, it means that I cannot wait or do these types of things. So I'm sacrificing parts of it in order to be run faster. And WebRTC is there. It's client-server or client-client. The latency is really very, very low, and that's the only thing that it can do. HTTP3 is somewhere over here, and WebTransport, which runs on top of HTTP3, you can say that it is somewhere here. It is there to work with very low latency. You can work with it without reliability at all. It's not centric, but it's not peer-to-peer either. It is still client-to-server or server-to-client. And people are now trying to use WebTransport to replace WebRTC. WebRTC is a bit heavy. And it is the notion of WebRTC is a bit heavy comes when you want to say things like, but I don't want peer-to-peer, or but I don't want turn servers. I don't want this whole ICE negotiation thing to be with me. If you compare WebTransport to WebRTC, you'll see that almost in everything, with WebRTC, it is built in. With WebTransport, it is left to the developer. Okay? And NAT traversal is not needed in WebTransport, or at least that's where the thought processes are. And the thing is that WebTransport gives us a simplified infrastructure. We can pick and choose the missing pieces that we want to implement using WebAssembly on top. Then we've got WebCodecs. WebCodecs is simple. It's just a browser wrapper for the audio and video encoders and decoders. Up until today, I could have used MP4 or VP8, H.264 or VP8 or VP9 or whatever in WebRTC. But if I wanted to do things my way, I couldn't inside the browser. Now I can, because it gives me a frame level API for encoding and decoding, and I can send and receive data however I want through WebTransport with. The only problem today is that it's available only in Chrome, and there are no mandatory to implement codecs. So understanding and knowing which codecs are available is still a bit of a problem there. The last one that I want to talk to you about is Codecs, specifically AV1. And it starts from the fact that there is a lifespan of codecs. If you look at the H.264 whatever codecs, then H.261, where we started before even I worked with computers, was somewhere in 1988. 7 years later, we had H.263. 8 years later, we had H.264. When H.264 started, I worked at a company called Radvision. It took time for H.264 to become commonplace. 10 years later, we started seeing HEVC as a codec. HEVC is H.265. It is still not fully deployed. It is deployed, it is available, but it's not the most common codec out there. H.264 is still a lot more common than that. And then we've got the VP8 and VP9 codecs here. And you can see that between HEVC and AV1, we have 6 years that passed. And since AV1 was announced, only 4 years have passed. Okay? Which means to me that it is still too new. So while we have a new codec available, and it is available in Chrome now, and you can use it in WebRTC, for the most part, for most use cases, for most users, it is too new to be used. Okay? But it is coming. And what we see now is that the larger vendors or the smallest startups are looking at AV1 and trying to figure out ways to actually use it. And the two main places that you see AV1 today are these. Either screen sharing, okay, or dealing with very low bit rates. Why is that? Because the advantages of AV1 is a very high compression rate, but it comes with the fact that it is very CPU intensive. So most hardware chipsets will not be able to run it at 720p, for example, in real time. It is royalty free, which is great. It has large industry backing. LG just joined, Snap joined before that, and almost everyone else is there. Even Qualcomm now announced that they are going to support AV1 in their chipsets. It supports SVC, Scalable Video Coding, which is important for large group calls, and it is somewhat available since Chrome 96. Again, only on Chrome. None of the other browsers have it yet. On the downsides, other than CPU intensive, is that there is no hardware acceleration yet. It is coming, it will take time, and when it will be there, you need to wait for these chipsets to actually come to market and for people to buy them and to deal with the fact that we have a lot of other machines out there that don't have these chipsets and hardware and acceleration, which means, again, that it is just too new to start using it today. Okay? So what have we seen up until now? We've seen that WebRTC is here to stay, it is growing in use, and there are new technologies that are being used and are there today, from WebAssembly to WebTransport, WebCodecs, and AV1. And these are parts of the new technologies that we're going to see in the next several years. And I think that one last thing that I wanted to stop at, and this is like the last slide, is that table stakes at video conferencing or even audio calls is changing. It's not the same as it were 5 years ago or even 2 years ago, which means that the type of feature set that product managers want to build or that end users expect is now very different. Nobody really cared about background replacement, for example, 3 years ago. Now, if you don't have it, that's going to be a problem. And these table stakes that are changing is something that I'm looking at and thinking for a long time now, and there should be an article coming up really soon on my blog as well.
All right. Thank you very much, Tsahi. And for our viewers, I'd like to encourage you, this is the time to ask any questions that you have. If you're watching on YouTube or on Twitch, just put a question in the comments. We'll see that here, and we'll answer those in just a moment. First, I'm going to tell you a little bit about a training program we have here at WebRTC that Tsahi's helped us with, by the way, and then we'll come back for your questions. As a viewer of WebRTC Live, you already know how important WebRTC development is to the modern web. Now it's time for you to grow your career by learning to build live video applications and joining our team at WebRTC.Ventures. Go to WebRTC.Ventures and apply to join the next cohort of our WebRTC training program. You'll have free access to advanced courses, mentorship from our team, and those who are accepted into the second month will receive a paid development contract and join our team of WebRTC development experts. Go to WebRTC.Ventures now and earn your place in our team of video development experts. All right. First, Tsahi, thanks for helping us out with that training program that we're doing at WebRTC Ventures. Definitely been a huge help for us. We just finished our first cohort of people coming out of that, and it's helping us to grow our team. I know you do that with other companies as well, so give you a little plug and kudos for that, and for everything you've done with WebRTCcourse.com. So the last point you were making there about table stakes is interesting to me, because on the one hand, you're saying that with the emergence of WebTransport and WebCodecs, WebAssembly, the way that we can unbundle our applications and get more control over how WebRTC is, or a alternative to WebRTC is implemented. But at the same time, table stakes like background replacement, you said, has to be there in applications.
Yep.
So how many of these things do you think will ever just be built into WebRTC, right? Because this is where I struggle a little bit, right? If I was talking to one of our clients, they're like, well, we have to have background replacement and everything, but now you're telling me I can't just use WebRTC. Your team's going to need more time because now we're going to build something based on WebAssembly, WebTransport, WebCodecs, which takes more work than sort of a standard, WebRTC implementation, let's say, right? How do you balance that?
So it's a question to Google in a way, or a question to the W3C where they standardize these things. And the balance needs to be made between what you place in the implementation versus what you enable and empower developers to do. Let's say that background replacement is done in WebRTC for you, or is done in the browser for you. You don't need to do anything, just put an enable to that like you do for echo cancellation. And it's there magically. Now, the problem is, what exactly do you blur in the background, or what do you replace? If this is for a gaming thing, then this is not the chair. Okay, my chair is not a gaming chair, and gamers would love to have their chair even when they replace all the background. Because that's like a piece of furniture that it's like they invest in it as much as they invest in the CPU that they use to run the game, which is ridiculous. But that's what they do, and you cannot remove that as the background.
Right.
Okay, and so you need to train the algorithm slightly different from that. The same goes for noise suppression. What do you suppress? I think that Serge did the most interesting thing when Google Meet introduced that, and he did an interview for The Verge. He said, okay, clapping. Do you suppress that? Because it's noise, and if it is, what if what we're doing now, we're the audience and we're clapping? Or this is a happy hour and we're clapping? So you can't even discern or know what is the intent of the user. So it's starting to become a little bit of a challenge to build these types of things, especially the ones that are related to machine learning, because you don't know what this context is. Okay, so a lot of the things that are done today is to try and check how do we enable them in WebRTC, and at the same time empower developers to do what they want. Now, this works really great for power developers or the professionals, but the ones that just come in and want to get things done, it's like, so what are you giving me here? These are ingredients. It's not I wanted a soup.
Right.
And it's like, and we're starting to see all of the CPaaS vendors, for example, adding these in. Most of
Yeah.
them today give background replacement. Why? Because it makes sense.
Yeah.
They don't.
Well, and I guess maybe that's a path. I mean, the gaming chair example you give is an interesting one, and the clapping as well, right? But if the vast majority of what they sort of, let's say the first time somebody's building a WebRTC based application, if that is still tends to be a one-to-one video chat application, then there's a lot of assumptions you can still make about that maybe should be baked in to libWebRTC, right? And then when you have that gaming chair use case, that's exactly why you should be going to WebTransport and WebCodecs, right?
Yes, but it kind of becomes bloatware.
Right.
Okay, I never use background blurring or replacement. I hate it.
Right.
That's my own preference. Okay, it's like, this is me. Say hello. That's my mother's picture. She painted it. I need to replace it at some point. I just didn't find anything in her house that I liked recently. And this thing, the kids bought it to me when they saw it because they said it looks as grumpy as I am. And that's me. And I'm talking to you. I want to reflect what I am and who I am.
Sure.
Others sometimes would like to blur it because it's not professional. People go in the background. I get that. I understand. I don't care about what they're doing.
Yeah.
In other cases, you cannot replace the background because the use case or the scenario doesn't yield itself to such a feature. It's not something that you want in your application. Okay,
Yeah.
so I no longer know what a common one-to-one call is. It really depends.
Yeah.
What's nice about it, though, to your answer, WebRTC is complicated. It always has been. It's a lot simpler than building these things on your own without it, but it is complicated. So if that's complicated, just go use Twilio, Vonage, Agora, Daily, whoever. Now, all of these CPaaS vendors today, they're adding these stuff in, but they're also, most of them are going towards the no-code, low-code approach, where they don't only offer you the APIs, but rather, here's the application. If that's all you want, use it as is.
Yeah, absolutely. Well, I'll give you a little statement of support here from our friend Dan Jenkins, who says he also hates background blur. So
That's
thank you,
probably
Dan.
why we're friends, me and Dan.
That's right. Well, good thing he answered that correctly then. Yeah, for any of you watching, any questions, please do put them in the Twitch or the YouTube. John Pierre notes, as always, Tsahi, great explanations on your part. And Nana LQ, the insight around context is everything. And yeah, I mean, I think this is always a challenge in any field, any vertical of software development, right? How far do you go in terms of building blocks and feature bloat? And certainly as technical people, we often love feature bloat in terms of things that we're building, but not necessarily things that we're using. So in any case, you made a point though about the CPaaS is kind of building in a lot of these table stakes. And so that's I want to dive into that a little bit more. Because that's interesting. We're going from having the original pitch of WebRTC being it's so easy. It's just a few lines of JavaScript to realizing, well, it's not quite that easy. You need stun and turn servers, but now it's not just a single path. There are all these multiple paths, right? We could unbundle things and build something really complicated. We could go with sort of a vanilla WebRTC in the browser implementation. We could go to a CPaaS, which not only takes away some of that implementation headache for us, but is now building in background blur perhaps as a default feature, so we don't have to do that, right? So when we think about CPaaSs in particular, or even the open source media server platforms, do you feel like we're also, if we're at peak WebRTC, are we also at peak CPaaS, or do you see clear differentiation between the CPaaS providers?
There is differentiation because there is no one size fits all. That's easy. And then we need to explain what CPaaS is. Okay, because anyone that slaps an API on his application to just give you a report at the end is to the CPaaS vendor. I'm not sure if you've seen that, but like all the press releases is, yes, we're doing CPaaS. We have an API. You can connect it to Zapier. But that's like, no, you're not. Um, and then inside these, some of them are good for the one-on-one interactions. Others are good for group calling. Some have HIPAA compliance, most but not all of them. Some do very good job at recording. Others go towards broadcasting, like 10,000 users. Um, so you need to understand what it is that you want to build, and then find the CPaaS vendor that would fit that if you need it.
Mhm.
And it's interesting to see that each one of them is trying to take a different approach and different direction. So Daily, for example, took the part of, you have a UI, just take it and you do nothing. That's it. It's an iframe. You want to play with the iframe, you can. You don't have to, but you can. A similar approach today is what JAS is doing, GT as a service from 8x8. But they take it almost a step further, like saying, well, it's Jitsi, it's open source. So there is no vendor lock-in. Look,
Right.
no hands. You can take it here, install it on your own remote server, or go the other way around, whatever you want, limitless. Others are we're going to build you an application. Agora has this marketplace and also an application builder. You go tweak a few things, you get source code that runs. Now, Twilio started going with Twilio Live towards doing broadcasts, but then there is a 2-second delay in there, whereas Agora has sub-second delay. And then Dolby, which focused on 3D audio, acquired Millicast, which are doing large-scale broadcasts with sub-second delays. So that's also another approach that you can now take with CPaaS. So these CPaaS vendors are actually going into different niches and trying to differentiate from each other in different ways. But they're all being pressured today by the table stakes part, background replacement. Okay, there's also noise suppression and a few others, and they're being pressured because I'm a customer. I want that to work, and I don't want you to tell me how I need to do this. I want a boolean that would just go true, and that's it.
Right. Right. Well, makes sense. All right. We've got another question from Jean-Pierre here. Wants to know, why do you think that the large number of people in grid view is not so important? What do you think is a reasonable number? And talk about the impact on devices, etc.
There is no impact on devices, not because there isn't, but it's a question of, first of all, the use case and what you need it for. And that would be the number. Yes, you need large number of people in the grid. There is this guy, I don't remember his name, a coach. He does these huge virtual events now instead of doing it in stadiums. And you see, like, he's got a board. He's using Zoom, but there's like a huge board wall with a lot of screens in front of him, about 1,000 people in there. So he needs a large grid. Why? To show that there are a lot of people.
Mm-hmm.
So it is needed. Now, I went once to one of the large universities in Europe for MBAs, and they had this project where they came and said, we've got these, the teachers, they want to teach classes, and they need to see the students, want to build them a wall with all of the people, and it's like, so they can see 50 students at a time. And I'm like, what? Like, who is the customer here? Is that the student or the teacher? I know teachers in universities, they don't give crap about the students anyway. If they see them or don't, they don't really care. They come, they say what they have to say, they go home. The good ones don't, but most of them don't care. And the students don't see that anyway. Whatever they see is on their small screen. And they see only the teacher anyway. So why invest and waste money on a large display for these teachers? Is that to attract the teachers? That's fine. But let's put it on the table. Why is it that you're using that? Okay, in a large call, usually end up, we did these stupid Zoom calls in the school, either for the class or the whole school or whatever. Everyone has his cameras closed, shut down beside the teacher. Large calls tend to have that dynamicity. You won't have a lot of open cameras anyway. So what's a reasonable number of grid view? I don't know. that depends on the use case that you have.
Yeah.
Most use cases today are fine with 2, 4, 10, 15, 20. And yes, 40 is great, 50 is great because you need that in your sheet, just for the feature list. But are you actually going to use it? Probably not. Go to the Zoom website, search for 49 grid in their support pages. You'll see that it's written there that it is available only on some machines. Why? Because they need to have the CPU for that. Which means that there is an impact on devices, but when there is an impact, we simply lower the expectations.
Yeah.
Okay, I'm not going to do 49 grid view on this phone, although it does do 10K. Not 10K, sorry, 4K or 1080p resolutions. It makes no sense to do this.
Absolutely. All right, different topic here. So talking about new technologies, Gerard wants to know about avatar animation. Are you seeing that in WebRTC applications at all, or
what is avatar animation?
Yeah, at least what I'm imagining based on Gerard's question here is the like the virtual event applications where you've got an avatar walking around the virtual room and you see video instead of their head, right?
I love these. We've got a few customers at testRTC that are doing that.
Yeah.
It's great because it's like, what? And then they come and tell you the number of minutes that they do, and it's ridiculously high numbers. So it seems that it is working. And I think there what happens is it's not, some of them are trying to copy the real world. Like if you go to the event space, there are companies that try to show you, okay, this is the, there is a speaker and we're going to put everyone around tables. No, you're not. I'm alone at home. I know what I'm doing. I don't want you to arrange me. It's not the same, so don't make it the same. And then there are those that look at the office and they build you a virtual office so you can move around. And yes, it was nice for the pandemic, but testRTC, we're all fully virtual. We've been that from the start. Some of the employees I've never seen besides on video calls.
Yeah.
Would it make sense for us to do such a thing with avatars? Probably. Okay, we don't do it today. So but it might make sense. It might bring us a bit closer together than we are today. Yes, I love the metaverse. Go read Ready Player One and be happy with that. Don't go to the metaverse. It will take time to get to the metaverse. Too many people are trying to do it today. Before that, it was 3D video. I think we had 3D meetings and holograms 5 years ago, and then it died down. And now it's coming up again. Wait for over 10 more years.
Yeah. All right. More general question here, and what is better, SFUs or MCUs from Pravin?
I'm not sure if my video is stuck or not, but
it does look like you are actually. Yep, I hear you fine, but your
okay, so I don't care. Stuck. So both. Is that a good answer?
Both are good. Yeah, both, or it depends, right?
Yes, exactly. So group calling, I would stopping camera and adding it back doesn't work either. Probably crash something, and I'm not going to refresh the browser for that.
Yeah, that's fine.
Large group calls, SFU. Everything that you can do with an SFU, do with an SFU. Why? Because it's cheaper. Only resort to an MCU when you must. And there is, I guess, today I've seen only one place where you must, and that would be what we're doing now, for example, which is recording. Even if we're streaming it live, that's recording for me.
Mm-hmm.
Why? Because viewing offline or in a different context cannot be done with multiple streams. So I need an MCU to mix these streams together. Other than that, don't touch an MCU with a long stick, simply because it's going to cost you too much.
All right.
There's a price issue here.
Yep, that makes complete sense. All right, and while we still have your camera kind of frozen in a slightly grumpy face, I'm going to ask you about Apple.
I'll stick with that face.
That's why I figured it would work.
Yes.
Apple's always been a little bit behind the other browsers. Safari being behind the other browsers, behind the other companies on WebRTC. Safari support has certainly suffered as a result in the past. I'm wondering if you think the same will be true with these newer technologies like WebTransport and WebCodecs.
Hard to say. My guess is yes, because they couldn't care less.
Yeah.
It's like, why should they?
Yeah.
What's the incentive for them to do these things at an orderly fashion, let's call it?
Yeah, absolutely. Well, hopefully they will still, so we're not going back to building our applications only for Chrome and Firefox, but we'll see.
Yeah.
All right. Well, I think we've had a lot of great questions. I appreciate everybody who's joined us today. And let's see, we have one more. We'll fit in one more here from Alberto asking, you talked about the newer browser APIs like WebCodecs and WebTransport. Are there any other more granular browser APIs that are coming that you think will be important for WebRTC applications?
No clue. These are the main ones, and they are the big ones.
Mm-hmm.
There are also small stuff like around the capture handle that we've talked to in the last WebRTC Fiddle of the Month a bit, with Hall of Mirrors. There is the ability to capture regions in the browser, or give some kind of pass information between tabs, these kinds of things. But nothing else comes to mind that is really, really interesting.
Okay. All right. And last question on my part then, and then we're going to close up here, Tsahi, but really appreciate your time today as always. What do you think the future WebRTC developer looks like with these different paths now that we can take for building a WebRTC application? Are they more of a JavaScript developer? Are they a DevOps infrastructure engineer? Are they somebody who knows the in and out of Codecs? Where are we headed? What are we going to accept? What do we call a WebRTC developer in the future?
The same as today. I think we've talked about it, or I sent you a question like 10 years ago or 7 years ago about that. Put that in an ebook with a few others with their answers. And it's like there are 4 different types of WebRTC developers almost. There is the one that does the front end, and he knows and understands the APIs, how to use them, the intricacies of them, and what that means to do them in a browser. Then you've got the full stack, backend, whatever. And that's usually the guy that would deal with the media server. Okay, he needs to understand speeds and feeds, codecs, RTP, all of the nuances there, and how to use them and what needs to be optimized. A lot of his work is also on the client side, but he's like on the back end. Then you've got the DevOps guy. That's because there are a lot more moving pieces in WebRTC than in any other HTML technology. And they are different in the way you manage, maintain, scale, or configure them for firewalls. So they need like their own set of expertise. And the fourth guy is the one that is doing mobile native apps. You need him as well. Usually 2 of them, one iOS, one Android. The usual stuff there.
All right. Sounds good. So same skill sets, but we've got a lot more options of how to build these now.
Yep.
Anything last you want to mention or plug? Where can our viewers go to learn more about you?
bloggeek.me and WebRTCcourse.com.
Awesome. Thanks so much for joining us again, Tsahi. Always a pleasure to have you on here. And thanks for being here. As always, for our viewers, this video will be available on the WebRTC.Ventures YouTube channel, as well as on our blog at WebRTC.Ventures. And our next episode of WebRTC Live will be Wednesday, April 20th. We'll be speaking with Professor Carl Stolle from the Illinois Institute of Technology. So to find out more about that and all of our upcoming episodes, follow us on Twitter at WebRTC.Ventures, on Twitch, on YouTube. Go to WebRTC.Ventures and join our email list. Thanks to everyone for joining us today. Let's make it live.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.Ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.